Thank you guys for joining my channel, and this video is going to be about how you are going to choose that what type of roof truss is actually suitable for your next project. Okay, so let's dive into the topic. At the very first, you know that there are different type of trusses from starting from the monoslope, that is the very simplest form of truss, to the bislope, or maybe sometime it is almost flat truss, okay, or maybe sometime it is something like sawtooth. Now in which case which type of truss need to be used? Not only that, let's say you are supposed to use this type of truss, and there also you can see that different type of varieties are there. Okay, so which type of shape or which type of truss is suitable? Okay, let's find out the actual logic. Okay, so there are mainly three criteria for selecting any truss. Okay, the first criteria is sloping criteria, second one is lighting criteria, and the most important is the span or loading criteria. Now why I am actually considering this a single criteria? I can consider it as two different criteria, that is span and loading, but I am considering this as a single criteria. Why? Well, at the end of the video you will get the answer. Okay, so first understand the very two simple reason, that is for sloping criteria. Let's say you are decided to construct a roof that will have a single or mono slope. In that case you can select this type of step. Okay, now let's say you are interested to construct a roof which roof has almost flattened finishing. So in that case you can use this type of flat type of truss. Okay, and if you find that no, I need a more drainage efficient roof, or where the snowfall is very much a concern, in that case you can use this type of bi-slope roof truss, where in both sides you will have steep slope. Okay, where the snowfall is a major problem, in that case they can use this type of bi-slope. Okay, and if you do not have any issue with the drainage, in that case you can use this type of flat type truss. Okay, and second case is lighting criteria. You know that nowadays the daylight saving is a very important criteria in running any type of company or industry. Okay, and they want to utilize the daylight as much as possible, and for that what they need to do, they need to ensure that they can allow the daylight to enter into their factory or into their safe. For that what they do, simply they provide some window panel at the end of each truss, just like this. Here you can see these are the window panel, these are the window panel, and for that which type of truss set need to be selected? Of course the sawtooth type truss need to be selected. Okay, so we have already covered the two simple criteria, that is sloping criteria and the lighting criteria. Now come to the final point, that is very important. Okay, so before discussing about the span and loading criteria, just a gentle recap, that is if you have a simply supported beam with uniformly distributed loaded and span L, so what is the bending moment diagram? Simply the bending moment diagram looks something like this, and the major or the maximum bending moment diagram occurs at the midspan, and it is something, let's say K times W L square. Okay, and what is the value of this bending moment? So this bending moment is simply a function of UDL or the load intensity and the span. Okay, so here you can see that the bending moment is the function of load intensity as well as the span. Okay, just remember this. Okay, now if you have some I section as this beam, how this bending moment is going to be transferred? Simply this bending moment is converted into a resultant compression force and a resultant tensile force, like this. Okay, this is the tensile and this is the compression. So simply if you have bending moment M and the lever arm distance between this compressive force and tensile force is T, then you have compressive and tensile force as m by, that is the value of compression or the tension. Okay, so here you can see that if we have a limited capacity of compressive force and tensile force, in that case, to, you can say that, to allow a large amount of bending moment, what we have to do, simply we also have to provide a larger depth. Okay, so let's say initially the bending moment was m1. In that case, depth d1 was sufficient. Now, if you have larger bending moment, that is m2, in that case you have to provide d2, that is greater than d1. Okay, and d is the distance between the topmost fiber or the point where the resultant compressive force is being acted between these 2 points, topmost fiber and the bottommost fiber. Okay, or you can say that the 2 points between the resultant compressive force and tensile force. Okay, now apply this simple concept into the truss. Okay, so here I have used span or loading criteria. Okay, we have seen that in a beam the bending moment was a function of UDL or load intensity and span. Now, what is the span here? In case of the truss, of course, this is the span L. And what is the load intensity? Well, the load intensity is depend on the spacing of the truss. Okay, so let's say in your building you have to use total 1, 2, 3, 4, 5, 6, 7 trusses. So based on their spacing, of course, the tributary area will vary. Okay, so this is the tributary area for a single truss. Now, for this whole length, if you use only 3 truss, in that case, for each truss, the loading area will be much more higher. Okay, so if the spanning of the truss increase, this load intensity also increase. Agree? And if you decrease the spanning, or if you simply put more truss in a lesser length, what will happen? Simply this UDL will be reduced. In that case, your bending moment will be reduced. Okay, so now I think it is clear to you what is the effect of span. Here is the span, this is the span of truss as well as the spacing. Okay, so this is the span and this is the spacing. Okay, now select one by one. First, let's say you have to use a flat roof. In that case, if the bending moment, this is the bending moment, if it increased, then the tension and compressive force also increase. Okay, and in any truss, if this is the truss, just consider this as the beam section. Okay, so these are the compressive member, these are the tensile member. Okay, so all of these forces are tensile force, these are compressive force. Now to cater any bending moment, what you have to do, you have to simply play with this lever arm or the distance between compressed member and tension member. Very simple. Okay, so if you have less bending moment, you can use this type of floor girder where the distance between the top chord and the bottom chord is less. And let's say you have to use the truss for a bridge. So in that case, you know that the bending moment is very much high. So you have to use a truss where the distance between this top member and bottom member is much larger. So here, if this is D2 and this is T1, simply D2 is much larger than D1. Okay, so what is the basis between this floor girder and K-type wave selection? The basis is simply the magnitude of the bending moment. Simply, again consider this type of triangular truss. So if you have less bending moment, you can use this one, flat truss. Okay, why not thin truss or the this type of mansard truss? Well, when this type of trusses are used, when the magnitude of the bending moment is high. If the magnitude of the bending moment is high, this distance, the magnitude is maximum at this midpoint. So if this is your truss, you have to increase this particular distance for a higher bending moment. Okay, now if this distance increase, here you can see that all this wave, these are the wave. Okay, so these are the wave members. So here you can see that these are the wave members, these are the wave members. So if this distance increase, let's say let's use some different color here. Due to higher magnitude of bending moment, you have to increase this distance. So now initially the wave member was, let's say this was the wave member. Okay, now what is the wave member? Now the wave member is this one, and these wave members are under the action of compressive force. So here you can see very clearly that this is the length L1 initially. Now this is the L2. Okay, and L2 is much greater than L1, or you can say that the buckling length of this member is much higher. So what you have to do? You have to strengthen, or you have to reduce the effective length by providing another members like this. Okay, that is the reason that these spring truss are used for higher loading, and these flat truss or simple truss, they are used for smaller loading. Okay, so I think you have understood the basics behind selection of any type of truss. Okay, that's it.